Okay, and we're back for part 2 of the limits analytically video. Okay, so I'm going to switch to my document camera. We're just going to do 33 and 38, and I think that should do it. So 33, just going to write that one down. Number 33 was the limit as x approaches 1/2 of 1 minus x minus 2x squared divided by 2x minus 1. All right, again, like so many of these, if you substitute 1/2 in for x, you get a 0 denominator. So we're gonna have to, as we did before, manipulate the expression so that we can find out what the limit is. All right, I always tell you to look for factoring first. This is factorable, okay? So I'm gonna just kind of pop this out a little bit so we can see. This is factorable, this expression. But what I'm going to do, because I don't like that it's not written in standard form, I'm going to rewrite it so it's in standard form, right? Descending order of exponents. So it's going to be negative 2x squared minus x plus 1. Okay, and I'm going to go ahead and factor that and put an exclamation mark. Factorable. I'm going to actually factor the negative out. Okay, so I'm going to leave this as 2x squared plus x minus 1. All right, so it just makes it easier to factor if I have a positive leading coefficient. Okay, you guys have done the factoring. You're experts at factoring with an a greater than 1, right? A times c is -2, b is 1. What multiplies to -2 and adds to 1? Right, so that's going to have to be 2x 2x minus 1 and x plus 1, right? Because if you FOIL these back together, you would end up with the original expression. Okay, so this is factorable. We're happy about that. It's a good thing. Okay, so now I'm going to write the original problem, but with this in factored form. So I'm going to rewrite it. Limit as x approaches 1/2 of negative 2x minus 1 times x plus 1, all divided by 2x minus 1. Okay. Now, some of you have already looked ahead and seen that this actually divides out to 1, right? So that's going to leave us with limit as x approaches 1/2 of negative x plus 1. So that means that x equals 1/2 is a removable discontinuity, right? Because it's basically canceling here. So now what we're going to do is substitute in the 1/2. Now it should be safe. So negative 1/2 plus 1 is -3/2 or -1.5. So our limit is this, okay, -3/2, and we're all set. Okay. All right, I have time to do one more problem, so we're going to do 38, which was another one that was requested. So 38 was the limit as x approaches 0 of 1 minus cosine squared of x times sine of x, all divided by x squared. Now, there are a ton of ways to do this. Again, if you substitute 0 in, you get a 0 denominator. So we're going to have to get creative with the way we write this expression. I've posted an answer key in Classroom, and that has a different way of doing it. So I'm going to show you another way. You'll probably remember, hopefully remember from our trig identities from pre-calculus, right? Sine squared of x plus cosine squared of x equals 1. That's one of our trig identities. So 1 minus cosine squared of x is sine squared of x. So I'm going to rewrite this as the limit as x approaches 0 of sine squared x times sine of x over x squared. Okay, and now I'm going to break these up. So What I mean by that is I'm going to simplify, I'm going to basically factor each of these expressions. So sine squared of x is just sine of x times sine of x, right? And then I have that third sine of x here. And then x squared is x times x. And another way you can look at that is that this is the limit as x approaches 0 of sine of x over x times the limit, again, these are our limit properties, limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of sine of x. This is what's so great about our limit properties that were on that slide from September 9th, is that we can use the limit properties to our advantage, okay? So this is a special limit. This is that same special limit, okay? So that special limit, limit as x approaches 0 of sine of x over x is 1. So we have 1 times 1, because these are the same, times limit as x approaches 0 of sine of x. Well, if you substitute 0 in sine of x, you get 0. So this is 1 times 0, or 0. Okay, so I hope that that helped. I think that's all we need to do based on what your questions were. I hope it helped. Thank you guys for watching, and I'll see you next time. Thank you.